Now in the section on Cauchy's and Legendre's differential equations, the first question is, what will be the transformed equation of question number 1, x square y double dash plus xy dash plus 9y is equal to sine log x under the transformation x is equal to e power z. This is called a Cauchy's equation, which has got the standard form a naught x square y double dash plus a1 xy dash plus a2y is equal to f of x. A Cauchy's equation can be recognized by x square in the coefficient of y double dash, x in the coefficient of y dash. Similarly, if you have a y triple dash, it must be accompanied by x cube. Such equations are called Cauchy's equations. Legendre's equations are slightly different, but having the same principle. It is known theoretically that x is equal to e power z transforms such equations to equations with constant coefficients. So, when x is equal to e power z, z will be log x, and simple calculus will tell you that xy dash becomes dy by dz, x square y double dash becomes d square y by dx squared minus dz squared minus dy by dz. In simple notation, we can write this as xy dash is equal to dy and x square y double dash is equal to d into d minus 1y, but we must be careful to know d is d by dz. That means there is a change of the independent variable from x to z. Right. So, what will now happen? The given equation transforms as what? D minus 1y plus dy plus 9y is equal to sine z, because z is log x. So, if you simplify this, you will get d squared minus d plus 9 into y is equal to sine z. So, you will get a second order differential equation d square y by dz squared plus 9y, there is no first order term, is equal to sine z. So, you can see this is the transformed equation corresponding to option A of the problem. Question number 2, we have another Cauchy's equation of the third order. It is given that it is getting transformed to an equation with constant coefficients with change of independent variable. So, x cube y triple dash plus 3x square y double dash plus xy dash plus 64y is equal to 0 getting transformed as d cube y by dz cube plus 8d square y by dz squared plus dy by dz and cy is equal to 0. You know that x is equal to e power z does the job as explained in the last problem. So, x is equal to e power z implies z is equal to log x, and as explained x y dash will be dy, x square y double dash will be d minus 1 into y. We also have x cube y triple dash in this problem. So, d minus 1 into d minus 2 into y. So, take this and substitute in the given equation, and you will have d minus 1 d minus 2 y plus 3d minus 1 y plus dy plus 64y is equal to 0, where of course you know what is d. D is d by dz. Let us simplify this. D cube minus 3d square plus 2d plus 3d square minus 3d plus d plus 64 into y is equal to 0. So, you will find minus 3d square cancelling with 3d squared, 2d plus d cancelling with minus 3d, leaving behind just two terms, d cube plus 64 into y is equal to 0. So, if you expand this, you will get d cube y by dz cube plus 64 y is equal to 0. Now, you compare this equation with the given transformed equation and you will get a is equal to b is equal to 0 and c is equal to 64. So, the required a plus b plus c will be 64, corresponding to option D of the problem. Question number 3. What is the complementary function of the differential equation x plus 1 whole squared y double dash plus 3 into x plus 1 y dash plus y is equal to 4x square plus x plus 1? Observe, this is not exactly a Cauchy's equation, but some related equation. This is the famous Legendre's equation. A Legendre's equation in the standard form will be a naught into ax plus b whole squared y double dash plus a1 into ax plus b y dash plus a2y is equal to f of ax plus b. So, you can easily see that this equation matches with the standard Legendre's equation. Now, here ax plus b is equal to x plus 1. The transformation ax plus b is equal to e power z is used to transform the Legendre's equation into an equation with constant coefficients, of course, with the change of independent variable. Now, calculus will tell you that ax plus b y dash is equal to a dy and ax plus b whole squared y double dash is a square into d minus 1 into y, where d is d by dz. Now, if this is applied to the given situation, you will find x plus 1 y dash is equal to a into dy, but a is 1, therefore, it is simply dy. X plus 1 whole square y double dash will be d minus 1 into y. Again, this a square becomes just 1. So, take this and substitute in the given equation. You will have d minus 1 plus 3d plus 1 into y is equal to, the right hand side can be converted into a function of z. So, this will be reduced to d square plus 2d plus 1 into y is equal to some right hand side, and when you solve the characteristic equation, you will get d is equal to minus 1 repeated twice. So, the complementary function will be c1 plus c2z into e power minus z. Of course, we can also write this as c1z plus c2. That is not a very important issue. Now, what about z? Because ax plus b is equal to e power z, in our case x plus 1 is equal to e power z. So, z is equal to log of x plus 1, and of course, from here you can write e power minus z as 1 by x plus 1. So, if you take this and write the complementary function in terms of x, you will have c1 plus c2 log of 1 plus x divided by x plus 1. So, you will find that option C matches with this. Of course, option C appears as c1 by x plus 1 plus c2 log of 1 plus x by x plus 1.